Okay, we're going to finish up chapter 7 notes wise. We still have a lot of assignments to work through because I think you guys really need to practice doing these problems, but we're going to finish up the groups. Okay, another carbonyl containing group, again with that double bond O, is something called an ester. And an ester is kind of like an ether where you had something in the middle to break it up. You had an O, but it's actually a double bond oxygen to a carbon and an O. So again, it splits it up into two groups, okay? It'll have a carbonyl group, the double bond O, and it'll have another O, okay? So it's kind of different. These are probably maybe the toughest ones to name, but they're really not that bad if you follow the rules, okay? They're called carboxylic acid derivatives. And to make an ester, you take a carboxylic acid and an alcohol and you put them together. So if you're going to name them, again, you got to look for not the longest chain, but you got to look for the chain that has a double bond O on it. You know, the one that has the carbonyl group. And it gets an ending. So like if it was 7, it would be, instead of heptane, it would be heptanoate. This is the one with the double bond O. And then you got the other side of it, you got to do as a substitute group. And again, it's easier if I just show you. Okay, here's one. All right, here's the double bond O. This right here is what makes it an ester. The double bond O in the middle of the chain somewhere. Okay, since they're not continuous, you can't just name this as one long chain because the oxygen messes that up. All right, so the way you name it is the guy that's got the double bond O, this chain. And again, it doesn't have to be the longest chain. It has to be the one that has the carbonyl group, and that's this one with the double bond O. So we got 1, 2, 3, 4, 5. So this side would be pentanoate. Okay, this side is a substitute group. It's 2, it's ethyl. So just be ethyl pentanoate. Okay, and again, if this had the double bond O, it would be pentyl ethanoate. So it's not the longest chain, you guys. It's the one that has a double bond O. So count it, and you change the ending, drop the E and add O8. That tells me there's this is an ester. And then on the other side, we just name it as a substitute group. So this is ethyl pentanoate. Okay, this one, again, double bond O. This is just the longer form. But again, we got this in here. Well, here we got 1, 2, 3. That's the one with the double bond O. So that would be propanoate. Okay. And again, this is an ethyl group, so it'd be ethyl propanoate. If this was another propyl group, you wouldn't say dipropyl, because again, this is a substitute. This is the main chain. So this is propanoate, and this is just ethyl. Okay. If this was a chain of 7, it would be heptanol. Whatever the amount is, that's what you put on the names. Okay. When you're looking at these carbonyl containing functional groups, again, esters, they have a permanent dipole too, but they can't hydrogen bond. So they do have strong intermolecular forces, but not as strong as like the carboxylic acid and stuff like that. Their esters are very, very common. You can make esters. We would have made them in the lab if we would have done this here. Esters, if you put them together, it's really simple. You put the two compounds together, you put a dehydrating agent like sulfuric acid in there, and then you put them in warm water, and then you let them like mix for a little bit. And you'll end up with flavors, like when you start, they smell awful. When you're done, you'll end up with things that smell like licorice, orange, citrus, flowery, all kinds of lovely fragrances come from esters if you get them completely reacted. They smell really good. One of the ones we do is banana, so you can, if you react them right, get really nice fragrances from esters. Okay. Another one is called, and we did a amine before, that was NH. Excuse me. If we have a carbonyl group, if we have a double bond O in there and nitrogen, then it's a little bit different. Okay. So we have, where we had amine was with an N, now we have an amide. Okay. And again, it's probably better for me just to show it to you, because if I go through these and not show it to you, it's like, okay, here we go. So before we had the NH2 and we said, we'd go 1, 2, 3, 4, 5, 6, 7. Oh, it's 6, sorry. 1, 2, 3, 4, 5, 6. And we just say hexyl amine when we did the other one. But now, because we have that double bond O in there, it's a little bit different. It ends in DE instead of NE. So again, 1, 2, 3, 4, 5, 6, hexaamide. Okay, so very similar to when we did amines, but again, we have this double bond O in here. This is our carbonyl group, and this is the one, we have aldehydes with this, we have carboxylic acids, we have ketones, this group right here. And there's a lot of organic compounds with that group in it, okay? So that's how you would name it. This is going to be on the end. This group is always going to be on the end because it can't be in the middle. There's too many bonded things here. So that's the nice thing about it. So you just do your count, your 1, 2, 3, 4, 5, 6, hexa, and then amide. That's all you have to do for that. Okay. Now, when you're looking at organic compounds, they have what they call stereoisomers. They're like mirror images of each other. Okay, they're the same molecules, same chemical formula, excuse me, but they have the same bonding arrangement, but they're the flips of each other. So the three-dimensional arrangement is flipped, and I'll show you. They're called Chiral images, and let's see. Oh, excuse me. They're superimposed on each other, so they're mirror images. And we're not going to spend a lot of time talking about this because this is a baby organic class. But if you ever take an upper level organic class, you're going to talk about these. And the reason why is they act different. Now, if you look, I mean, it's the same thing. But this side where your oxygen's on the inside is L. Okay, and in this case, we have the amine groups. You know how you can see they're just mirror images of each other. Okay, so this one, we have the NH group, your amine group on the, it starts with it, and this it ends with it. So this is an L and this is a D. I'm going to show it to you. We're not going to do a lot of stuff with it, but again, if you take an upper level organic, you're going to talk more about these because they actually do react different, but they are mirrored images of them. They're called stereoisomers. Okay, and again, we're not going to spend a ton of time on those. I just wanted to show them to you so they're not totally foreign. Okay, the center of the chirality, what they call it, is a tetrahedral carbon. So you have carbon in the middle with 4 bonds. And again, that's what carbon does. Oh, goodness. So you can see this is the center right here. And they're just opposites of each other. Okay, so L and D. And again, those are stereoisomers. They're the same molecule. They're just flipped. And they react different. We're not going to worry about it because we're not really talking about reactions. This is, a 100 level organic. So I'm going to teach you how to name the compounds, what they look like, how to draw them. And if you take organic, like if you transfer somewhere else and you have to take upper level organic, you're talking 300 and 400 level. They'll do much more with this. But I just wanted to show it to you so you saw it. And this is the end of it all. This shows you, double bond, triple bond, aromatic. This is just a kind of and this is, I got right out of your book. What I'm going to do after these notes is I have kind of a cheat sheet, if you want to call it that. It tells you what the endings are, what the groups are, and whatever. So you can use that. I would print it out and use it to help you name these things. Because from now on, even though we're done with the notes, I'm going to have more than just one assignment like I normally do after lecture, because we need to really practice these, okay? So there's going to be a few assignments. Excuse me. And then if you want to use that cheat sheet to practice, it'll help you when you take your test. Okay, so we are done with the notes. And again, this summary you'll see in there. But I have a little cheat sheet for you. It'll probably work better than just looking at this. Okay, all right, so we are done with chapter 7 as far as the notes are concerned.